this function and this function. This is a parabola. What's the vertical stretch that started this thing out? 2. Okay? So you take the y equals x squared parabola and you stretch it vertically by factor 2, it gets a little skinnier. This one has a vertical stretch of -1, or if you prefer, a vertical stretch of 1 and a reflection through the x-axis. Okay? Which means it's going to be an upside down parabola, but it's just as fat as the y equals x squared parabola, which means it's twice as fat as this one. So this one is down, this one is up, and this one is skinnier than this one. Now that doesn't ensure that these parabolas intersect, because a downward parabola can be completely below an upward parabola, can't it? Okay? Or maybe they only intersect at the vertex, so at one point. But usually if they intersect, they're going to intersect at 2 points. Now I picked my numbers here, my 2 and my -7, and I didn't make these numbers too big, so I was pretty sure that these were going to intersect. Okay? Now how do you get the intersection? Well, how do you get the intersection of 2 straight lines? You set the equations equal, right? Okay? How do you get the intersection of 2 parabolas? We set the equations equal. How do you get the intersection of any 2 curves? If you know their equations, you set them equal. Now maybe you can solve it, maybe you can't. Okay? I mean, there are many things that nobody can solve. Okay? So anyhow, we want to find our points of intersection, and that occurs when one function is equal to the other. So this is equal to this, right? Now there are 2 ways to solve this. One way is you write down these 2 things, and then you eliminate one of the variables, right? Now try as you might, you're not going to eliminate x out of these 2 because the coefficients of x squared and x are in different proportions here, so there's nothing you can multiply that'll fix that. But what we could do is, and of course if you add these, nothing goes away, but if you were to subtract them, the y would go away, right? So we do this, and then we take, we write down the first one, we write down the second one, but we take its negative, and then we add them, and we get this, right? And then if we solve this for x, we know the x coordinate of the intersection, right? Okay? Now that's closer to what you might be used to doing, but another thing you can do is you can say, well, if y equals this and y equals this, then this equals this. So we can set this expression equal to this expression and solve. Okay? Now if we do that, the easiest way to solve it, well, first place, how are you going to solve this? Well, you still want to use what you do with linear functions, even though I told you early in the semester you need to be able to identify when you don't have a linear function, because you can't do that if you don't have a linear function. I mean, sometimes you can, but not always. Okay. Especially you need to identify when you've got a quadratic function, because the way you solve a quadratic equation is with the quadratic formula. Okay? Now many of you have been doing that. Okay? Many of you know that, but you know, it's about half and half, I think. Maybe not even half and half. Okay? Some people are shaky, and most people are at least shaky on that. This is a quadratic equation. You can't put all the x's on one side and the numbers on the other side and get anything at all that makes sense. Doesn't stop you from doing something and getting a wrong answer, but it's not going to work. Okay? You have to violate the rules of algebra to get even any kind of a solution. You have to use the quadratic formula, or you have to be able to complete the square. Okay? Or maybe you can factor. Usually you can't factor. So there are other alternatives, but the quadratic formula is the one thing that always works. So you have to understand this is a quadratic equation, and you also have to understand that this is a quadratic equation. Okay? Now, if this was, instead of a negative x squared, a 2x squared, then you could subtract the 2x squared from both sides, and it would become a linear equation, wouldn't it? But that's not going to happen here, is it?
No.
Okay? Because the coefficient here doesn't match the coefficient here. Okay? So you can't get rid of the x squared, at least not by any valid step that keeps the equations consistent, you know, that doesn't change the solutions. So what we're going to do is we got to get it in the form here, because this is what the quadratic formula tells us, right? Okay? If your equation can be put into this form, then you can use the quadratic formula. And that's what you're generally going to want to do. So I put a big red circle around this. To solve a quadratic equation, put it into this form and use the quadratic formula. Now again, if you can factor it and solve by factoring, that's fine. Okay? If you don't have the bx in there, you can solve it. We've seen how to do that. But in general, if you don't have any other good way to do it, you use the quadratic formula. Okay? So we put this equation into this form. Can we put this equation into this form? Well, apparently, because I seem to have done it. But do we know how to do this? Okay? Easy enough. We want 0 on one side. So if we just subtract all this stuff from both sides, we're going to get a 0 over here, right? So we just subtract this whole thing from this side and from this side. And, well, if I wrote this down right, if this is the same as this with the minus sign here and the parentheses and all that, okay, then you got to get 0, right? Now over here you get what you get. So we do minus that same thing. We distribute the minus sign, we get this. We collect our terms, and here's our quadratic. Then we solve the equation. Now, if the first thing I'd ask you to do when you walk in here is write out the quadratic formula, I think a lot of you wouldn't have been able to do it. Tuesday, make sure you can do it. And keep it for the rest of your life, because you're going to use it a lot in homework. Okay? And you need to know the quadratic formula. No big shame in coming into this course not knowing the quadratic formula. I think I mentioned I went to a pretty high-level school that didn't offer anything under a very hard calculus course. And half of the students didn't know how to do the quadratic formula, and this is back in the time of the space race. Okay? I knew how to use it. I knew it real well, which put me ahead of at least half of the people in my class. And my class was not the top level calculus class, but it was a little above the normal calculus class. Okay? Then all I'm saying is, then I was probably in a class with top 5% students, and half of them didn't seem to know it. So if you came into the course not knowing it, no shame. If you still don't know it, no shame. But if you don't know it Tuesday, shame, shame, shame. Right? Okay? So, to solve this, well, we just use the quadratic formula and we get the solution. Done. I'm not going to go over it. If you want to see it, look at the video. Okay? But we just, very straightforward, we get a solution. Now we get an exact solution, and then I get approximate solutions. Because I didn't want to plug this exact solution with the plus minus square root and all that stuff into the equation. It wouldn't have done much good, wouldn't have done anybody much good. Okay? Because usually you're going to go to an approximation, although I do want you to be able to do the exact solution. So, we take that, we get these two approximate solutions. Perfectly okay to punch this into your calculator, you know, square root of 7, who knows what the square root of 7 is. I knew it was between 2.6 and 2.7, but I kind of thought it might be closer to 2.7. And it was just a little bit closer to 2.6, so you know, I didn't try that hard. Okay.
So we approximate, like you say, it's closer to 2.6, so we say 2.65.
You could. But you're going to use a calculator, and usually I want you to approximate to 3 significant figures. I didn't write these down to 3 significant figures because I was doing this in my head. Okay?
That's what I'm saying, like, are we doing it in our head? Cause I told you, like,
Yeah, if you're
I
doing
ain't
it in your
good
head
with
for a quick and dirty calculation, that's okay. Although usually you're gonna use a calculator to approximate it, okay? If this was 17 instead of 7, what's the square root of 17? Yeah, it's pretty close to 4.1, but, you know. What's the square root of 73? Well, I think I could probably, if I think about it for a minute, give you a good approximation. That's pretty close to 8.5. So, yeah. So it's good to know that. It's good to be able to do enough arithmetic in your head to at least see if these numbers make sense. And then that's exactly what you just did. Okay? But not everybody's going to be able to do that. If you got to use a calculator, just do it carefully. Okay. Anyhow, we get two solutions. Quadratic formula, identify A, B, and C, plug it in and do it. Everybody can do that. I've seen everybody do that. Okay? You do that, you get these approximate solutions. What's that tell you? Let's go back to these two curves. You got 2 points where they intersect. At one point, x is about 2.2. At the other point, x is about negative 1.5. Okay? Now, to get the points, you're going to need to find the y values, right? How you do that? Yeah, you plug that x value in to either equation, and if that x value is right, it's going to tell you the y value. Now, that x value isn't right, it's an approximation. This is right, I think. This is an approximation. This is exact, this is an approximation. Okay? Be a pain to plug this into a quadratic, although you could do it if you remember to use a distributive law. Okay? So just plug the approximation in. If I plug the exact value in, I expect to get exactly the same y if I put it in here as if I put it in here. Okay, they equal. But if I use an approximation, I'm not going to get exactly the same value of y. Okay? Now, if I use a good approximation, my y values will be pretty close. If you approximate to 3 significant figures, your y values will probably be close, but very likely to 3 significant figures, but at least to 2. Well, anyhow, I plug negative 1.5 in, and it turns out I think I get exactly negative 7, if I did that right in my head. And I wasn't sure at that point if I'd done it right, but I kind of thought maybe I did. That's plugging the negative 1.5 into the first equation. Plugging it into the second equation, I got negative 7.25. Well, is that close?
yeah.
That's close enough to make me think that my 2.2 wasn't a bad approximation. Okay? Now, if you use a 3-digit approximation that you got using your calculator, you expect it to come out much closer than that. Okay? I've said, okay, let's say negative 1.5, negative 7.1 isn't going to be far off. And if you do it with a calculator, you're going to get much closer. Okay? And then I plug the 2.2 in, and I didn't do that. Okay? Let's see, you're going to get like negative 4, negative 2, and 11. You're going to get about, oh geez, I'm getting like 9. It comes out a lot bigger than it are. Anyhow, I don't like it. That's probably because I screwed it up. Okay? My mental approximation. If you square 2.2, you get 4.84. I think you get 4.84. So I was a little off. Anyhow, there it is.